Welcome to FRSC 2130, Fire Service Building Construction. My name is Adam Roberts, and I will be your instructor. My office is on the Athens campus, A Building, Office 109. Even though this is not a live lecture, you can still reach me by email at aroberts@athenstech.edu or by phone, 706-357-0162 if you have any questions. Also, I will be available in Blackboard Collaborate Ultra for a Q&A session, basically virtual office hours, and that'll be posted in the course calendar. Okay, let's get started. Okay, in this introduction chapter, Chapter 1, we will cover the following objectives. First, list the 3 influencing factors that allow firefighters to perform interior operations. 2, identify the 3 new building trends that are reducing firefighter safety. 3, outline the commitment necessary to help achieve safe fireground operations. And 4, describe the challenges that exist for conducting relative building size-ups. Now, it is very important that you pay attention to the lectures as well as read the text. Don't substitute one for the other or vice versa. There'll be quiz questions, test questions coming from the lecture and the textbook both, as well as any additional online assignments that you may have. As you can see here in the picture, here's the picture of our text, The Art of Reading Buildings, and it is by Dave Dotson and John Minterdorf. This particular chapter is divided up in 4 sections, and we're going to talk a little bit about each section and highlight a few key things that I want you to pay special attention to. So in the first section, we're going to discuss why this book, why now. The next part is some overhead issues and concerns. 3, ways for you to maximize this book to further your education and knowledge. And finally, 4, the chapter review exercise. Why this book, why now? And let's look at the first 2 together. And the first 2 bullet points are society has changed the fire and society has changed the buildings. And this kind of goes hand in hand. The fires are now burning hotter and faster, and this is due to the introduction of more synthetic products and petroleum-based products, not only in home construction, but the furnishings. So when these products burn, they burn a whole lot hotter than our traditional, what we call legacy construction versus this new modern lightweight construction. So with this new lightweight construction, everything is built so it is energy efficient, it is lightweight, it has less mass, meaning that things aren't as thick. Now, are they as structurally sound as your legacy construction or the older homes? And yes, they are just as structurally sound, if not even stronger. However, they are unfortunately very receptive to fire, meaning that they just don't hold up as well to direct flame as the older building material. Now, also with this energy efficient construction, these homes are airtight. So in the past, our fires were fuel driven, meaning once the room and contents were burned up, the fire was going to go out. But now what we have is this airtight construction that makes the fire go from being fuel controlled to being air controlled or vent controlled, meaning the fire is going to burn in a house or in a room till all the oxygen is used up. but there's still plenty of fuel in there in the form of smoke and gas and other products being complete combustion, and it's just waiting on the introduction of oxygen for it to flash over or backdraft. And this is something that we'll talk a little bit more later on in this text and more in depth in other classes. So when we look at the third bullet point, it says current curriculums do not address rapid recognition and tactical relevances. So what they're basically referring to here is that there are two main texts out there that are very great, and I've taught from both. But one just basically deals with what buildings are built and why they fall down, basically how. And the other goes into the fact of, why they fall down. Both these texts do a great job in talking about how things are built and why they collapse under fire conditions, but it really doesn't translate well into the firefighter on scene and being able to extrapolate from those into a good street knowledge to keep everyone safe. And this text does a great job bridging those gaps and bringing them together and making a nice cohesive program to help you better understand building construction as related to the fire service so that you can stay safe, you can do your job, you can get your crew home, and you can put the fire out. Through incident responses and building familiarization activities, firefighters are discovering new and innovative building materials and methods that collectively reduce the amount of time that firefighters have to safely put out interior fires. Unfortunately, new construction methods are not usually designed to help firefighters in this task. Considering the cost of labor, equipment, and building material, it is not economically feasible today to construct a structure the same as those from the 1800s and early 1900s. Again, that's that legacy construction versus the modern. In many cases, the heavy timbers of the legacy construction have been replaced by 2x4s of varying lengths and having certain finger joints that are basically just glued together in a lightweight truss configuration. And we'll go more into what a lightweight truss is in Chapter 2. But just understand that things are not as built as solid as they once were in terms of mass. The mass has changed, replacing with stuff that is a lot lighter and a lot more cost effective. So this leads to a decrease in the mass and a change in the chemical makeup, which causes the fire service to lose three valuable factors that allow us to safely put out the fire. And that is 1, safety, 2, time, and 3, relative building size. And we'll go more into that. To take a step back for a minute, when we look at when I was talking about the glued stuff and the trusses, that's basically collectively known as engineered wood. And again, we'll get a good definition of that in Chapter 2. So it's replacing that concrete and steel, that tried and true, hey, it's going to hold up to fire, to something that's just as structurally sound. It's lighter, it's cheaper, but anything that's glued together, guess what? You expose it to heat, and it's going to fail. It's going to fall apart a whole lot quicker than, say, steel, where a steel joist can withstand 1,000 degrees for say 8 minutes versus 1,000 degree on a engineered wood. It's going to fall apart in a matter of seconds. In the next few slides, we're going to examine each of these three factors more in depth that are reducing the amount of time that firefighters can do interior firefighting operations. So it's important to know that time, of course, is always against us, but again, with this new construction, we're having less time, more difficulty with size up, and safety is an ever-growing issue. In the text, it has an interesting little blurb here in the introduction of the safety section, but basically, NFPA reports incidences that firefighters suffer injury or death on a structural incident, basically a house fire, are a result of three primary factors. 1, it falls on you. 2, you fall into it. And 3, flashover. And all this is directly related to the new construction. Basically, the house falls on you, you fall through the floor, or the building flashes while you're in there. Now, with the new approach in building construction, it focuses on two main concepts, and that is math and cost. And I mean by math, they're talking about geometry. They're using modern mathematical concepts to make things just as strong, if not stronger, using angles and other principles, as opposed to large mass, meaning heavy-duty pillars and columns. And by switching over again to this math and cost building approach, and cost obviously is something they want to keep down. So how do you keep costs down? I hate using the term you make things as cheaply as possible, but you use products that are lightweight and obviously cheaper than the predecessors, which again leads us to issues in terms of fighting fire and safety. So that gives you basically the 3-strike policy, or issues, to use a baseball term. And with the, again, math and the cost approach in building construction, it leads to 3 strikes. And what happens with 3 strikes? After the 3rd strike, you're out, right? And basically that means firefighters are possibly going to get hurt. So now we have lower mass, which again, the lighter weight stuff doesn't hold up to heat as well. 2, you have engineered shapes for the structural elements, basically the geometry again. And 3, you have better insulation. You add all this stuff up, and on the fire ground, it can be the recipe for disaster. Now, this book is going to help you with your, quote, fire ground office. That's where you go to work at in terms of knowing what you have to deal with and become familiarized with. But you're also going to have to take a few steps on your own and make sure you're doing the proper things in your area, doing fire prevention inspections, walkthrough, and your basic familiarizations. Look at homes when they're being built. Talk to the builders. See what kind of materials that they are using in their structure, and every day there's something new out there, and see how it's holding up. And on safety, I'm going to read this on page 3 because this is a very important section. It would behoove you to remember this section because you may see it again. Safety is not something that just happens automatically at a fire ground, and or something that always arrives unannounced when necessary. It is a commitment you make to be familiar with your surroundings, operate in a predictable and standard way, and train at every opportunity. Remember that training is the most important non-emergency function that we do, and typically pays immense dividends in the form of safe fire ground operations. So again, you want to train, you want to do your due diligence and be familiar with your area, and you also want to operate in a predictable manner, meaning you have a routine. You follow that routine. Not saying that, you're going to fight every fire the same way, but you're going to have a certain system of checks and balances that you're going to do every time that's going to dictate your action or your plan to safely mitigate the situation or put out the fire. Time is always against us in the fire service. The longer a structure is allowed to burn, the more it loses integrity and the more of a foothold gravity is allowed to take on the structure. And gravity wants to pull everything down to earth. So once gravity wins, the structure is going to come crashing to the ground, whether you're in it or not. On the fire ground, there are two clocks that are referenced in the text. One is the pre-arrival clock, and that's in reference to how long has the fire been burning before anyone noticed, and how long did it take to dispatch the call. Now, we don't have a whole lot of control over that clock, but we do have to be mindful of it, because that time ultimately helps dictate how much time we're going to have to do our evolution, meaning put the fire out. Now, once the first two apparatus sets the parking brake on location is when the second clock, the fire ground clock, starts. And let me say this again. Once the first two apparatus sets the parking brake on location is when the second clock, the fire ground clock, starts. And we're going to go more into this later on in the text, but I want you to remember that right now. Okay? Remember, time is a constant. You cannot buy it or sell it, and you must be aware of its constant passage. With each click of the clock, the fire is actively weakening the structure, because our fires are dynamic. They are not static. Dynamic meaning that they are always changing. They are not staying the same as in static. And with each click of the clock, fire is destroying the integrity of that structure. Again, allowing gravity greater control. And gravity will eventually win, because the structure will be weak enough and it will come crashing to the ground. Gravity is always a constant factor we deal with. Of course, that clock is going to continue to run even when we're doing our operation. So until we make good headway on the fire and begin to pull it out, put it out, it's going to continue to weaken the structure. Once that first due engine arrives on scene, it's the duty of the officer on that engine to do a relative size up. And that's defined as the ability to quickly determine an applicable impression of an incident that lays the foundation for a safe abatement strategy that continues until the conclusion of the incident. Again, the definition of a relative size up is the ability to quickly determine an applicable impression of an incident that lays the foundation for safe abatement strategy that continues until the conclusion of the incident. To put it in layman's term, the officer gets off the engine, they do a 360, they walk around the building, they decide what they're dealing with in terms of the fire and the building construction, and they come up with a plan on how to put the fire out. And they continue with that plan until the fire is out. Fundamentally speaking, the fire service is still fighting fires in buildings the same way that we had for 50 years plus. You still got to advance hose lines into the structure. You still got to perform searches. You still have poor visibility, and ventilation plays a key role in getting smoke and heat out. However, what has changed is the number of buildings we face in terms of the different styles. And we'll talk a little bit about this in the text, and especially in the next chapter, on the 5 different types of building construction. Type 1 being non-combustible, 2 limited combustible, 3 Main Street America and regular building houses and things of that nature. But we can no longer pigeonhole every building into one of these 5 types of construction. So we need to start changing the way we're looking at our different types, and understand that, granted, you may have some that have features of one, but it also may have others that have features of 2 or 3 of the different components. And of course, we can tell everybody to get a good familiarization of their area and look at the buildings to get a good palette of what's going on, and try to stay up on technology and materials that are being used, but that's still going to create a gap in issues in terms of our size up. And you want to do a good size up because that's going to dictate how your scenario is going to go. And one thing I'd like to point out, if you look at this slide on the right here on the top, you see a picture of a building. This building appears to be what I would call modern construction. It looks very new, so you would expect principles based on math and, of course, lightweight construction. However, we look on the inside, and that's the photo on the bottom. You can clearly see, and you see a better picture in the text on page 5, figure 1-2, that the inside is significantly different from the outside. And what I mean here is, if we look at it, we see beams that are heavy timber. We see walls that aren't insulated in heavy masonry. So the inside of this structure really appears to be something that is that heavy timber type construction versus the lightweight modern construction. And again, heavy timber is an example of that legacy construction. So once you get inside the structure, you realize that it's that heavy timber, so you're going to have more time on that fire ground clock versus that of a legacy construction, depending on what's burning and how well involved the fire is. With modern construction, relatively small fires can have potentially catastrophic effects. And in the text, there's a scenario here where this factory warehouse appeared to be a very minor fire, nothing too terrible involved. But once they got in and put the fire out, and you can see in the picture on the left where you've got a V-shaped pattern going up where the fire started, and it was allowed to spread up the wall and continue to the roof. And once you get to the roof, the fire had enough heat, enough flame, where the truss system was burned away. All this in here should have been supported. The roof should have these cross members going back and forth supporting the roof, or what they call an I-beam or an I-joist. And you can read more about that in the text. So with this modern construction, this is a good example of how the modern construction did not hold up well to the heat. And what would happen if you put somebody on this roof weighing 200, 300, 400 pounds? It's quite possible they could fall through. Or if there's some sort of dead load on there, meaning like an air conditioning vent, something that's fixed to the roof, and at a given point you're in there trying to put the fire out, and then the AC unit comes crashing through the roof and falls on top and kills or injured someone. The best way to get your education and your money's worth out of this textbook, it has 4 basic areas that they're going to focus on. One is building your foundation in terms of building knowledge. It's going to incorporate components and firefighting practice lessons for you to use. It's going to have a rapid street read guide reference, and it's going to have other features such as summaries and case studies. So I encourage you to take full advantage of this text, obviously, because it would help you in passing your quizzes, your assignments, as well as your final. But it's going to give you a good knowledge base on how to safely operate on the fire ground and size up what you've got. Which brings us to Chapter 1 review exercise. So for your homework, or one of your homework assignments for this chapter, I would like you to answer the following questions. What are the 3 influencing factors that allow firefighters to perform interior fire operations? 2, new construction methods have affected firefighter safety in a negative way. What are the 3 trends contributing to that impact? 3, how can safe fireground operations be improved by individual firefighters? 4, what modern influence is reducing building integrity, parentheses time, for all buildings? And 5, what does the phrase relative building size up mean? 6, list several factors that challenge the ability to conduct a relative building size up. Now this is listed in the appendices for your text, but I want all your answers on this to use in-text citations in APA format. And there's a link in the lessons page to help you with your APA format. And what that basically means is you're going to answer the question, you're going to paraphrase the words of the text, and then you're going to list what page you found that information on. So it would be like the 3 influencing factors are X, Y, and Z. Again, put in your own terms. And then at the end of that sentence or paragraph, whatever the case may be, it's going to be a parentheses, the year, comma, the author or authors, and then the page reference. And there's a great APA guide link, again, for you to use as an example. And you'll be graded on grammar. Did you answer the question? Did you use APA format in terms of the grading rubric? Okay, again, if you have any questions, feel free to call or email me, as well as I'll be available for the open office hours / classroom and Blackboard Collaborate that are listed in the calendar. Thank you very much, and hope you have a good day.